Hello, Happy New Year. This is the Xtar Dragon VP4L Plus lithium ion and nickel metal hydride battery charger. Here it is charging two of these Xtar, what are they? 21700s. Yes, that's right. 5000 milliamp hours. And you can charge them at half an amp or 1 amp or 2 amps, but you can only use 2 amps if you only use the outer two bays and if you don't have anything in the middle bays. I think if I put one of these cells in a middle bay, it will revert back to 1 amps. Yes, it does. Now I have 4 cells in the charger, but you can only see the data, which is percentage charged and milliamp hours for 2 bays at a time. If all 4 are populated, then you tend to get 2 and 3, or the other option is channel 1 and channel 4. You can only see 2 sets of information simultaneously. And this charger breaks one of my golden rules, which is that I want all my battery chargers to show voltage, because this one doesn't show voltage. Well, not in the normal sense anyway. And it doesn't actually show current either. I mean, you can see the current that you've selected, and we know these cells are charging at 1 amp. But when these get up to about 90%, of course, they hit Vmax and they go from constant voltage into from constant current into constant voltage, and therefore the current will start to come down. And you don't see that here because this just shows you what current you've selected. And so I have found myself taking sneaky voltage measurements like this, 3.72 volts, and this one is 4.24. So that one, channel 3, which is at 79%, is actually at Vmax, so it's doing now a constant voltage charge, so the current will be coming down. And I've also found myself measuring current by counting these flashes. They're approximately 1 second each. So if we wait for a change on here, which is there, 31, 2, 3, 4, 5, 6, 7, 8. So it's about 8 seconds per change. Now it's there's a factor of 3.6 between hours, of course, and seconds. So 8 seconds is half an amp. So I now know that this cell in channel 3 is charging at half an amp because it's reached the maximum voltage and the current is being tapered back. So certainly I do miss the voltage and current indicators, but there kind of are ways around it. Now any button will bring the display from its dim mode back to its bright mode, and then there are 3 buttons here. This one's labeled current and refresh, this one is display, and this one is record and test. And although most of the button functions are in this manual, which is supplied with the charger, I found it necessary to produce a cheat sheet to tell me what all the buttons do, because they do different things with a single press, with a double press, and with a press and hold. Okay, let's take a quick look at the box. Humanistic sound reminder. And I saw on the front of here it had record there. And I thought that it spoke to you and said, your batteries are charged. But it's not that. I don't know what humanistic actually means, but I think it just means that the sound reminder is neither too loud nor too quiet. Test battery voltage and resistance like a multimeter. Yeah, let's do that next because that's really interesting. You can do lithium ion, nickel metal hydride, and eliminate the memory effect function of nickel metal hydride batteries. Well, that's really more nickel cadmium, isn't it? Now this does actually say that it can charge 1.2 volt nickel metal hydride and nickel cadmium from quadruple A all the way up to D size cells, and it can do lithium ion cells right from 10-440 right up to 32-650, because these bays are actually quite wide. And the L version of this battery charger, this L here, means that the charger has these longer bays. And so you get, over the non-L version of this charger, you get the ability to charge protected 2700 and 21700 cells. So these are actually protected 21700s. This pouch bag is supplied, and it's quite useful because there are a few accessories. This is the mains power adapter 12 volts 3 amps, but that doesn't tell you what range of input voltage this thing will take. It just says 12 volts on it. Well, the clue is this, the car cigarette lighter adapter, because this could have on it up to 14.5 volts or possibly down to 11 volts. So we know that the input on this charger takes a wide range of measurements. But this is the other thing you get. It's this pair of probes, and I'll look at that next. Well, actually, let's take a look at the socketry next. Let's turn it around this way. So here's the 12 volt 3 amp input. We know it has a wide voltage range. Now there are two USBs marked USB 1 and USB 2. Let's put a little light in these. USB 1, it doesn't light up. I don't believe it's actually a USB output. USB 2 provides USB 5 volts, so you can charge a phone or something like that. And in fact, that will even work if I pull out the 12 volts. Okay, not quite UPS mode, so let's bring these cells away. I might have to bring them all away. Right, and so now it will use the cells in the charger as a source of power, and it's running in sort of power bank mode. USB symbol is there, so the USB is providing power. Let's have a look at that. Yep, that's 5 volts USB on there. Let's just try this socket again. No, there's no 5 volts on here, and that's because this socket is used in conjunction with the probes. Let's have a look at that. So to get into battery testing mode using these probes, you touch them together and it goes into this mode where it shows you voltage and milliohms. And now it's a case of putting the black probe on the negative side of your battery. Apply as much pressure as you can so that you get a good contact. And now we should see the voltage of this cell, 4.07 volts, and the internal resistance, 90 milliohms, 4.07 volts, and 85 milliohms. Let's try a bigger cell. So a 21700 cell, and we have 3.95 volts, 26 milliohms. Oop, my probe is slipping. 3.96 volts, 38 milliohms. So the bigger the cell, the lower the internal resistance typically. And of course this test is not limited to lithium ion NMC. The battery charger is, it can't do lithium iron phosphate, it can't do titanate, certainly can't do sodium ion, but I can test the voltage and internal resistance of this sodium ion cell using the tester, because all it's telling us is voltage, 2.6 volts, and internal resistance, 68 milliohms, 2.6 volts, 68 milliohms, nice and consistent. Let's get another sodium ion cell. Or an LFP cell. This is lithium iron phosphate, a little AA size one, 3.33 volts, 66 milliohms, 3.33 volts, 66 milliohms. Right, let's try this 33140 sodium ion cell. Should have a lower internal resistance than the others. And it's 3.25 volts, 5 milliohms, or even 4 milliohms. Now, of course, the milliohm reading is only to 1 milliohm, so that's the resolution you've got. Perhaps not enough for these big cells. Let's try an even bigger one. Okay, let's try this Hikari 46145 sodium ion cell. And that is 3.14 volts, 2 milliohms, 3.14 volts, 3 milliohms. Now this is where you need the cheat sheet. So to exit the internal resistance mode, you need to double press the display button. So that gets you back to charge. I'll put a couple of cells in. Okay, let's look at the refresh and test modes. To get into refresh, press and hold the left hand button. It's marked refresh, so there it is. Enter refresh, hold the current refresh button, and this does a DC, so a discharge and then a charge. So let's put the cells in and watch it do that. And the lights go blue when it's discharging, They're green when they're doing nothing, and they're red when it's charging. So these two cells are discharging, and you get this sort of moving down animation. So yeah, refreshes discharge and charge. Although I have found if you put nickel metal hydride in here in refresh mode, the first thing it does with those is charge them. So for nickel metal hydride, it seems to do a charge, discharge, charge. And I'm not entirely sure why, because the test mode does charge, discharge, charge. So let's go into test mode, press and hold test. It goes into test mode. Now that does a charge and then a discharge, and it measures the parameters, milliamp hours, I think it measures, and then it does another charge, and I think it stores the discharge measurement and the charge measurement so that you can compare them to see whether you're getting losses due to internal resistance or heat or things like that. So back to the cheat sheet. To look at the recorded data, we need to do a single press on this third button. That lets us examine the recorded data. So you can see that recorded data 2, and this is something I did previously, was a charge. Oh, actually it was a charge of this not very good lithium ion cell, and it recorded in charge mode 244 milliamps and in discharge mode 242 milliamps. Yes, it has a very low capacity, that cell. And if you happen to charge and discharge and have recorded data for all 4 bays, again, you switch between them using the display button in the middle. So I wasn't recording any data in channels 2 and 3. In fact, I only had the cell in channel 4. And to move forwards and backwards through the recorded data, you can use the left button to go back to record number 2 or back to record number 1. And again, move between channels 1 and 4 or 2 and 3 using the display button, and use a single press on the record button to move forwards through the recorded data. And you can see that from my cheat sheet here, exit the recorded data is a double press on display. The first press brings the light back on. So now a double press. Yes, and we're back to the standard charge while we're in test mode. You can come out of test mode actually just by pressing and holding test, and now we're back in the standard charge mode and all 4 cells will charge. So how have I found this charger for charging lithium ion cells and having no voltage indication? Yeah, it's not really a problem because you know that the voltage is climbing up to about 80%, and then at 80% we're at that maximum of 4.25 it is on this charger. And you know then that the current is falling down, and you can do this counting flashes thing to guesstimate the current. But the percentage indicator is actually quite good with lithium ion because it's a very simple, predictable charging curve. What about nickel metal hydride? Okay, nickel metal hydride, one of the things I find when you have a device that takes 4 cells is that very often when the cells are near flat, one of them will actually be pushed into negative voltage. So let's see what the unit does if we have negative voltage, and I'll simulate that by putting it in the wrong way round. And it simply says error and beeps quite frantically, not so humanistic when it's not happy. But you can get this when the cell's the right way round, but just at 0 volts or slightly negative voltage. Now you can shut the sounder up because there's a sound off function, on and off it is actually. Double press the right hand button and that mutes the sound. Now all the battery chargers I've got struggle, well some of them very often struggle with a cell that's at 0 volts or ever so slightly negative. This one's not too bad. It will complain and it will make that indicating buzzing sound, but if you simply disconnect the cell and then reconnect it, and then you might get the error sound again. You just simply disconnect it and reconnect it a few times, and generally that will instigate a charge of a cell that is completely flat. Like most battery chargers, this thing does occasionally make mistakes with nickel metal hydride in that it doesn't take them right up to 1.5 volts, and it can slightly undercharge them, terminating at about 1.4 volts. That's where I found having a battery tester that shows you voltage is quite handy. You can take the cell out, just check it, and if it's at 1.4 and it's not fully charged, put it back in for a bit more charging. The other thing I found with this charger, and it is common to all nickel metal hydride chargers, if you charge at 1 amp, then these are quite warm when they finish charging. So what you could do if you happen to be watching the charger is when they get to about 80%, just knock the current down to half an amp. You can actually charge nickel metal hydrides at 2 amps on here if you don't have the center 2 bays occupied. I think 2 amps is probably a bit heavy current for these 2000 milliamp hour or 2 amp hour nickel metal hydrides. And I did find an undocumented feature. This is not in the manual. If you're doing a refresh charge, so this is doing a discharge and then it will do a charge. It seems to also include a mythical first charge, but that might be because that's actually what it does on nickel metal hydride. But double click the left hand button and you can actually switch it between what the charge parameters were and what the discharge parameters now are. And when this has done a discharge and it goes back to charge mode, you can double click to toggle between the discharge parameter and the current charge data. Undocumented feature. So what's my conclusion on this charger? I think it probably is quite a good daily charger for nickel metal hydrides, with that caveat that you just check them when they come out to make sure that they are fully charged. Definitely make sure you create a cheat sheet for this, because it's impossible remembering what these 3 buttons do in their 3 different single click, double click and hold modes, 9 functions altogether. It's a fully featured charger for lithium ion, does half an amp, 1 amp and 2 amps, also does this discharge charge and also the charge discharge charge, which is the test mode. It has power bank mode, so it can use the cells in the charger to provide a USB output. And if I switch on the external power, the USB output is maintained, but possibly there's a little timing gap in there. And also, of course, if I switch off the 12 volts, then it doesn't immediately switch over to using the cells in USB power mode. You have to disconnect them and reconnect them, and then you can use it as a power bank. But I think what I might find most useful for me is these test probes, where you can measure the internal resistance of really any cell. So big thanks to Xtar for sending me this Dragon VP4L Plus battery charger and internal resistance tester. Purchase links will be in the description below the video, but that's it for this video, so cheerio.